and welcome to the Next 100 Days podcast. My name is Graham Arrowsmith.
And my name's Kevin Appleby. Graham, being interested in model making, I've always had a fascination with 3D printing. And we had my mate, Justin Noble, on the podcast quite a few weeks ago, who's 3D printing very small things, 3D printing buildings, for instance. What about 3D printing a full-size house?
Oh, I know. We've got the world's expert on the podcast. We're really privileged to have Anna Cheniuntai on the podcast. Welcome, Anna, to the Next 100 Days podcast.
Hello. Thank you very much for having me. That's a huge pleasure being here and having the opportunity to tell more about what we're doing and how we aiming to change the world and make the housing truly affordable and available.
Now, I must ask you a question before we start diving into that. Graham's got a reputation on this podcast for getting the guest's name wrong. Did he get your surname right there, Anna?
Oh, yeah, absolutely. He did a great job.
Yeah. What can I say? What can I say, Anna? You really. I slipped Anna a few quid before the podcast to say that. No, it's not true. Anna, one of the things that your company is called Apis Cor. That's APIS space and then COR. Where did that name come from?
So basically, the idea came from the honeybees. So Apis meaning honeybee from Latin.
Oh,
and honeybees, they're the first who ever started using extrusion process to build their homes. So we have been inspired by them. Yeah. And so COR, it means heart on the from the Latin as well. So basically the inspiration came from the first 3D printing builders in the world, the honeybees.
As you know, we can't live. The world won't survive without bees. So, I mean, what a great name and a great title. So
that's fascinating. I've never thought of 3D printing effectively being invented in that way by animals building or insects building hives and nests.
Mm.
Yeah, and actually, a lot of things come from the mother, from the nature, right? We really incorporated a lot of things that actually initially was created by nature, and all of the shapes, even in the design and architecture, you can see that a lot of ideas implemented that actually were inspired by nature. So yeah, we should be very thankful to nature for everything that inspired us.
Now we're going to get onto this, but your ambition isn't just about Earth, is it? Your ambition goes beyond Earth.
Yes, exactly. So basically, what we're doing is the robotics and autonomous construction technology. And it's obvious that the robots is going to be the first to build houses on Moon or Mars, like anywhere beyond Earth. Even today, the robots are the first, the only, the only, how to say it?
They're the only sort of living thing on Mars, aren't they? So, well, it's not really living,
exactly.
is it? But operating.
They're the only ones who live in there. Yeah, exactly. Yeah. And so what we're doing is like, let's say in 10 years, when the technology is really like there, and not only our technology, but also the space rockets, or like the biggest rockets, like a Starship, is ready to actually deliver very heavy cargo there. This is where we can also may have a chance to start printing something there. So this is the idea, is that by applying the 3D printing technology, autonomous construction technology here on Earth, we're going to learn a lot. And then we will apply this knowledge how to actually build something beyond Earth. Of course, the robots is going to be different, the materials is going to be different, but the actual fundamental approach, it's kind of can be pretty easily applied beyond Earth.
I've been thinking about this because I met a colleague of yours, Edgar Munoz, in London last week, and we got talking about this. And I asked him the question. I'm not sure if I remember the answer, but if you're on Mars, would you sort of scoop up the the soil or whatever to create the materials to create the accommodations?
So the main idea how we actually can do something there, and the way that we should pursue to build something on Moon and Mars, it's how we can use as much local materials as possible.
Right.
Because that bringing something from Earth, it's going to be very expensive. So we need to find a way how we can bring from Earth as less materials as possible. And of course, the regolith that are available on Moon or Mars, it's going to be the basic material that we go into, let's say, mix with some other material in very less amount that we can bring from Earth. So we believe that it's not really possible just to use the local regolith.
Right.
It has to be mixed with some like a special compound to make the material suitable for construction. So it's just the question and the task, very challenging task, how to create this technology, method, and approach that we use very little amount brought from Earth. And so this is the question, what the materials and how the process of basically like putting them together in some structure, how this technology going to look like. So that's not a very easy task, right? So that will require a lot of research and development, testing, and trying a lot of different ideas. But basically, you're right, that we're going to use the local material regolith, somehow mix it and build.
Do you think that it will be in the span of your career when that happens?
Yes, I believe so, because you can see how the other technologies and companies really evolving pretty fast. So I'm a big fan of SpaceX and what they're doing. So even today, we can see that they built a huge rocket that is the first step to make anything possible to do on Moon and Mars. Yeah. So I believe that you can see it, right? That it's pretty something that's going to happen pretty soon. So once they have rocket, then a company like us, get chance to actually start bringing robots there and start testing something. So yeah, seeing how all of the technologies have been evolved for the last 10 years, that for me, it's like a very obvious that, yeah, it's going to be in my career and I want to be part of this.
That's good. I think Kevin and our careers might be over, but we'll be watching from our deck chairs thinking, oh, look. Or maybe we'll get a free pass to go up there, Kevin,
Well, you never know.
You could open up the Newcastle United Supporters Club on Mars. That would be,
that'd be a first, idea, wouldn't it? Yeah.
I will try to get you a special discount,
I like the fact you said SpaceX because you may not know, but I've just bought a Tesla, so I just love the Tesla, and I think Elon Musk is a massive power for good in the world. Is not entirely conventional, but I love that about him. I think and SpaceX is such an important way to get ourselves into the place where you can actually help the world, and future worlds exist.
Yeah, absolutely.
Anyway, Graham, we're in the world of science fiction still at the moment. Okay, science fiction is becoming close to reality. Now, come back to today. What exactly does your company do today, Anna?
Yeah, so our company is the developer of the unique and one-of-a-kind technology to 3D print full-scale houses on site. So as you mentioned earlier, it's not like the small prototypes of homes that you can put on your desk. It's actual full-sized houses. And so the process is pretty similar to the traditional plastic 3D printing, with which almost everybody familiar with today. But instead of plastic, we used very strong and durable concrete material. And instead of small 3D printer that typically sit on your desk, like a desktop printer, we use larger machines. So we actually can print something larger, something like a house. And so then the machine is deployed on the construction site and start printing the desired shape of a building by laying the concrete layers layer by layer, and then you basically get the shape, the shell of a house, the wall structure. And so our company has been pioneered this industry since 2016. And so we have delivered a pretty several landmark projects that are not huge milestone for our company. Those projects, they basically the really a significant advancement for the entire industry. So for example, we 3D printed the largest building on earth for Dubai government. It's a 2-story, beautiful, pretty big administrative building. It's about 30 feet tall and about the 6,400 square feet house total area. So this is huge, and it's still not something that other companies can overcome or do something even bigger. So that actually was possible because of the true innovation of our technology, and specifically the design of the robot. So robot that we designed and built, it's fully mobile and transportable. So basically you can move the robot and keep printing the wall structure literally until the land is ended, so the land is the limit.
One of the real benefits of that, and actually you call that robot that you can move around, you call it a name, don't you?
Yes. Yeah.
So what is it called?
The name is Frank. And we also have 2 other units. So Frank is the one guy who doing the actual extrusion process. We also have Gary. This is this custom built mixer and the pump machine that actually delivers the material to Frank. And we also have Mary. Mary, it's the big bulk truck, bulk trailer that actually delivers the, let's say, 60 tons of material to the construction site. So yeah, we have a family: Frank, Gary, and Mary.
And was there some inspiration for those names? Because I wonder if you had colleagues with the name Frank, Gary, and Mary. I wonder where those names came from.
So Frank, that was inspired by Frank Floyd. It's one of the most recognizable architects. And he did a lot of really great designs and architecture projects. So we really wasn't inspired by him. Gary, it's really just, we took it from the cartoon SpongeBob because it looks like Gary. When you see it, that really looks like Gary. Yeah. And Mary, just something that kind of very elegantly can, finish the Frank, Gary, and Mary.
I like this is a female founded company, and I like the fact that the biggest thing that you've got has a female name. Love it. I just think it's brilliant. And but one of the
subservient workers have got the male names.
Yeah, one of the but they do the really clever stuff as well. But one of the things that really sets you apart is the fact that you can do quite intricate designs on site, which other people are not really able to do. And that's really, it does set you apart because it means that you can do all kinds of housing projects, now and in the future.
Yes, exactly. So the only limitation that we have today, it's how many floors you can actually 3D print. So we limited it's up to 3 floors, because if we print up to 3 floors, we still can comply with the building codes for the concrete block construction. If you go high rising, it's a kind of different construction approach and technology and everything. But today we build basically the low-rising houses, and again, the square footage of the building, it's not a question. So we can build a single-family home, we can build a mall, or even the big storage. So this is basically the main thing that we can do.
And I know that the kind of, if I said to yourself, I'm thinking of investing in Apis Cor, one of the things in my mind is that I've got three or four different things in my mind, but what is the problem that you're trying to solve?
Oh, yeah. So the problem is basically the outdated traditional construction industry today. So the traditional construction cannot keep up with the demand that we actually need to deliver worldwide. So for example, the housing shortage in the United States, it's more than 5 million houses. So the 5 million houses have to be built to meet the growing demand. And we are not there yet. And the problem is that we rely on a skilled labor, which is really limited today, very expensive. And basically, construction companies cannot increase productivity to build more homes. So the speed of construction is the problem. The cost of construction is the problem, the quality of construction is the problem. So we have the problem of basically affordability and availability of new houses. Yeah. So the innovation and basically the autonomous technology has to be introduced to the construction industry to increase productivity, right? So this is the problem that we're trying to solve by introducing the robotics to the construction.
And I know that one of the things that the construction industry, even over here, suffers from is aging. A lot of people in the construction industry are slightly older than the average. And so before long, they'll be retiring and they won't be coming back. And the people are struggling to find people to move into the construction industry. What you're doing is actually creating a new type of person moving into the industry, aren't you?
Oh yeah, exactly. That's a great point. When we're saying like the problem of skilled labor, it's not something like people don't want to work or we don't pay them enough. We don't have enough people to show up on the construction site and do the actual work. Yeah. And it actually, for example, in the United States, and that came from after the crisis in 2008, a lot of people from the construction industry, they went to different industries, and now they basically are not going to come back. They live in a lot of unfilled positions. So it's more than 400,000 unfilled positions in the United States. And even the construction companies offering the pretty decent salary, people are not going to go there. And younger generation, they're not really attracted in a, very hard physical and dirty work. So who would like to, even I wouldn't like to, go to the construction site and put it together, the bricks with the concrete. So that's the problem.
But you are actually creating the opportunity of robot managers, if you like. And I mean, construction is very male dominated, but a robot operator doesn't have to be male.
Oh, yeah, exactly. So this is what we also do with the robotics technology. So it used to be, construction industry used to be male dominated because it was the very hard physical work, right? But today, if you're using our technology, for example, women like me can start the construction business and start printed houses, because basically what you need, you have the pickup truck and flatbed trailer, and that basically this is enough to really transport our equipment from one side to another side. And I don't need to hire like a 10-man to help me to transport, deploy, or assemble the machine. I can just use the joystick and the printer basically like wheels on the concrete slab and start printing. So this technology really opens opportunity for women like me, for the retired people and the younger generation.
Oh, retired people. Well, that's all right for Kevin and I then. That'll be fantastic. We can go over to America.
This is our ticket to Mars, Graham. Retired people can operate the kit.
Yeah, working your ticket to Mars. Yeah, I think you might have to build a lot of houses. However, I love that idea, but because it's not. What we're going to do is on the show notes we'll put a video of, because it's mesmerizing when you see how the walls are constructed. If you haven't seen it, you really must find that video, and you can go to Apis Cor .com, apis-core.com, and you can find those types of videos. But we'll definitely put one on the show notes. But
absolutely, and you've seen more about this than I have, Graham. I'm fascinated to see it in operation.
It is so. The key thing is you're actually building walls, Anna, aren't you? That's what you're doing.
Yes, exactly. So the technology today is how to increase the productivity of building the shell of a house.
Yeah.
Because shell of a house is typically the most labor intensive and material intensive part of the construction. And if you don't have a shell of a house, the walls, you cannot put the roof and windows, right? There is no house if you don't have the walls.
Yeah.
But actually, our company is also developing the turnkey solution, how we can actually expedite the entire construction process. So the 3D printing technology allows us to also innovate the remaining part of the construction, like a roof, for example, or how we install the mechanical, electrical, and plumbing as we print. So technology really allows to introduce a lot of innovation approaches to expedite the overall construction process.
It's an amazing change, the way in which we're building houses. But you build houses something like 9 times quicker than traditional methods.
Yes, but it would be more correct to say that the shell of a house, the walls, they can be constructed 9 times faster rather than traditional concrete block construction. And since you really save a lot of time here, and you can also innovate the remaining part of the construction, the entire construction time to get a finished house can be really short, as like a 2-3 months compared to 8 or even 12 months that you spend today just to get the finished house.
That's a huge saving, and it means that you can cut the time to putting roofs over people's heads, in America in particular. And I know that you're focused on, I mean, your company's based in Florida, quite close to, is it Cape Canaveral? Am I the right one? So you're handily placed to get on those rockets and go to Mars and the moon. But but your services now, and Kevin's told me off once that we should talk about where we are now. But basically, your services now, what you want to do is to sort of expand to the southern states of the United States, aren't you? That's what your plan is.
So yes, that's correct. But our market is basically global. So be it the construction industry is huge, and it's really the affordability and availability of the houses is the problem in almost every particular country. And market is really like different from the United States to UK to even Philippines, for example. So, but the technology that we do is pretty science intensive, I would say. So we prefer doing like a step-by-step growth plan. So we start with the United States, and specifically southern states of the United States, because here in the states like Texas, Florida, South Carolina, almost half of the amount of the single family houses built there. So for example, this year is projected to build more than 1 million single family new homes, and about half of them are going to build in the southern states. So we try to focus on the most urgent markets, I would say. And once we are really like have the infrastructure ready and have the product ready to scale internationally, then we go to the different markets worldwide. Because
in a way, it's not quite a gold rush, because if it was, then you'd be getting all the gold, because to be honest with you, your solution is so, it seems to be ahead of your competition. One of the things that your competition does do is that they use gantries, which are kind of these metal sort of structures where the printing process can be can go from. There is a problem with that type of solution, isn't there? It's not as flexible.
Oh yeah, exactly. So basically what the other companies do, they basically took the desktop printer for the print the plastic things, and like, okay, let's do it like 100 times bigger. It's like this box on steroids. It actually weighs like more than 10 tons, of course, depending on the different designs, but it's very, very heavy. And even if you have the pickup truck and flatbed trailer, it will not help you. So you will need to hire the very heavy duty truck that can handle like a 10 tons or even more of the payload.
Yeah.
And then you need to get maybe even 10 people just to, deploy this machine on the construction site, kind of set it on the construction site, operate it. So it's very, very heavy. And the construction industry, it's all the time about the logistics. So if you want to introduce the innovative solution, we need to understand how that product, that innovation solution, really can fit the exact needs and really can cut the cost without creating the new logistic costs. So this is the difference.
Some of the competitors at the moment are struggling where you're not. Excuse me. And one of the things that you really, one of the things that you do is you extrude through this, through the frank thing, the actual cement mortar. It's a very closely guarded secret as to what and protected secret as to the constituency of the cement that you're laying. So they obviously are trying to replicate that, but they're having problems in terms of the way in which it's extruded and the fact that it cracks and so forth. Yours doesn't.
Yeah, so the material science and the material part of the technology it's a really huge thing, because for example, you can extrude even the sour cream, for example, or clay, right? And it can be extruded. So the extrusion process can happen. But we're talking about the actual houses where people are going to live in, right? So the material, has to be very durable and strong, not only extrudable. And so this is pretty like a significant scientific task to create this material. And so we have been very, very advanced in this. So for example, we created the material for a project in Dubai. The material we used, it was extruded in the natural conditions, in the harsh conditions, in the basically desert in Dubai. Yeah. And so we also have the material that we tested in Boca Chica, Texas. That material is basically the super cement, which is about 10,000 PSI. So it's very, very strong. Yeah. So the other companies, they have their materials, because you actually can create a lot of different materials that can be extruded and kind of strong, but the actual physical properties can be completely different. And you can have cracks even after a month, for example, because it's pretty complex process how to properly extrude it. And you can see that among the houses built worldwide, first, they really have a very strong sausage effect. So basically when layers, they look like sausages. Yeah. And if you have this sausage surface, you need to spend a lot of money for the finishing. So you basically need to spend way more plaster or stucco to make the wall smooth. Yeah. And cracks, you also can see that some of the houses, they have cracks in the material. It's not structural cracks, but again, like you don't know what exactly can happen later.
And your Gary mixer, I was told that one of the reasons that it's almost like a sealed unit, because you wouldn't just sort of throw material on the top and do the mixing open to the elements, because effectively all that air would get in and you'd have bubbles, wouldn't you, in terms of the mix. So that you've obviously thought about the way in which Gary is mixing the materials that are then going to be extruded onto the walls. Was that a big challenge for you?
I would say that it wasn't a very big challenge, but the idea of creating this specialized mixer for 3D printing, it came from the actual practical experience. Right. Because when we were 3D printing building in Dubai, we used a pretty standard retail mixer that you use for like a plastering or something like this. And it really didn't work properly for the purpose of 3D printing the house, because the material is pretty high viscosity material. The consistency of the material is different. So it was a lot of clogs in the system. So we just realized, no, that's not the way how the technology should work if you really want to scale it and print the buildings with the consistent quality. Yeah. So basically, we just put together all of the knowledge, all of the feedback, and then we realized, okay, we need to build our machine. And so Gary is really built specifically for the 3D printing technology.
It's another example, Kevin, just as you said right at the beginning, is that as a new company, Anna, you've had to pivot from one type of approach where, because you're a pioneer, you're doing something and you find, oh, it don't really work as we wanted it to, so we're gonna have to change it. And these are not small things. I mean, if you're building a building, it's quite a big investment. So, but now it seems to me that you're making more right decisions than wrong. And that don't get me wrong, I'm sure there'll still be challenges for you, but the good news is that you're obviously doing something right now.
Yeah, because we did a lot of mistakes too. So you cannot figure out what is right until you test all of the theories and see how it actually works. So we had also a lot of, now it sounds like a funny stories when, like a concrete was splashing around, like in our team, they trying to run out of this. So that everything that we do now, it came from actual practical, real experience. Yeah. And so this is one of the really, I would say, huge advantage of our company is that we really think about the technology itself, because the solution that you use, that's going to define if you're going to be successful as a business, if you're going to be able to scale the technology, right? So we really spend a lot of time to have this, I would say, really advanced equipment and technology that then can be easily scaled up from in the United States, in UK, or in Africa, wherever. But you have to have the right solution first.
Yeah. So Anna, it sounds as though you've put a lot of time and effort into developing that solution, developing the machinery to do it. Now, I presume for a new company, that's cost quite a lot of money. How have you funded this so far?
So we started, me and Nick, we are two founders of the company. So before Apis Cor, we were in the business of the industrial machines. So basically we were building industrial machinery like a CNC routers or CNC machines. And then we got a contract for Olympic Games. It was a pretty huge contract, cost $6 million. And we basically needed to design and build and deploy the ground navigation system for millions of visitors coming to the Olympic Games. So we basically were responsible to not getting all of these people lost. And so that was the time when we made our first big money. And then we just decided, okay, we saw how the construction industry outdated because we are really very close to it. And then we there is a space in the construction industry when we can introduce robots, and that can be a very big thing. And then we okay, let's invest all of our money in this. This is how we started. And then we got the project in Dubai, then it's what the NASA awards. And in 2020, we were selected into Alchemist Accelerator. It's one of the top startup accelerator in Silicon Valley, specifically for B2B startups. And so they funded us. And then we also had angel investors in 2020, 2021. We funded by At1 Venture firm. They basically invest in the companies that really trying to solve the big problems. So they invested in the artificial meat, for example. They invested in robots that increase productivity with growing the plants or something like this. So they really invest in the companies that do the positive impact on the health of the earth. And so now we actually doing our current big fundraising. We have been qualified by SEC, the Security Exchange Commission by United States, to raise money from public. So basically, today, everybody can invest in our company, accredited or not accredited investors. And we wanted to do this because we saw how people really inspired and they want to be part of this big change. And we just realized that people like me or you, they can be the ones who really can affect the big change in our world. And so we're raising $35 million now. And again, everybody can be part of this big
I certainly have some understanding that the interest in Apis Cor is absolutely amazing, and I'm sure that the 35 million will be eaten up very, very quickly. But the beauty of that is that you're making the case to investors. You've given us an idea of how the system works. What will you use the money that you raise for? I mean, presumably it's all about scaling now.
Yeah. So we right now in the phase when we have the product that we, as you very correctly noticed, we spend a lot of efforts to make this product ready to go to the market. Yeah. So basically, we're going to spend money to build more machines, build the infrastructure for the material production, because the material production, as I said, the material itself, it's a big part of the technology, and it has to be properly mined, produced, and delivered to make sure that the construction companies using our robots, they receive the constant and very high quality builds. So this is for the material infrastructure, and also expanding the workforce, because we need all of the great people to help us with the exponential, the great growth that we expect in.
So your market is to be selling the machines to construction companies rather than build the houses yourself.
So we have two strategies: penetration strategy and the actual growth strategy. Yeah. So penetration strategy, it's when we as a company, we build homes using our technology, because we need to show how actually it works. We need to increase the customer acceptance. A lot of companies, they want to use technology like tomorrow, let's say, but we have a lot of inquiries and the demand is really impressive. But we want to make sure that those companies, they will be successful in using our technology. And first, we want to do this by ourselves, right, in large scale. Yeah. And then we go to the growth strategy when it's like the main business model, when we rent out the machines and also sell our 3D print material. So basically our business model is around the 3D printing material, kind of like a HP, let's say. Yeah. So it really allows to make the recurring revenue on supplying the material, and also make sure that the robots are used properly, and the end result, the house, is built with the quality that we need, with all of the structural integrity that it's needed.
So you're effectively operating a lease the machine out model rather than a sell the machine?
Yes, correct.
Yeah.
It's interesting. One of the things you said there, Anna, is that you really want to help the construction companies use the machines properly. So one, I believe you've been quite selective about your partners, but two, you've actually developed a university to help impart the sort of knowledge that people involved in this area can actually take themselves up the curve a bit.
Oh yeah, exactly. Because this new technology, even if people really want to start using this, they're really excited about this, but they still need to have some education, right? And this is what we found out, that our potential customers, they really need to be educated, even on the very basic things in construction, or how the material for 3D printing works, how the different machines and 3D printers operates. And it also helped with the building officials and government officials for them to get like a really understanding how it works. And it helped us to also promote the technology and push the boundaries, because the education is a huge factor to scale the technology as well.
I imagine there's got to, in this process, be some sort of mindset shift that you're automatically thinking about how traditional building works and how I can swap traditional building with new technology, where actually once you get into new technology, as certainly my limited experience with 3D printing in small scale is that technology is one thing, imagination around what you can do with it is a big factor. So you're not just simply substituting old methods of building for new methods, you're effectively opening up a huge new area that hasn't been explored at all yet in construction.
Mm.
Oh yeah, exactly. Because the 3D printing technology allows to implement designs that used to be very expensive with the traditional materials, or even impossible at all. So we can easily 3D print the curved walls, right? Yeah. And for machine, there is no difference. It's a straight line or completely like a curved wall. So yeah, that's the very great notice that you did. Yeah.
Yeah, I think one of the things that I understand is that a recent survey in Florida, a real estate survey, 66% of those who answered the survey said that, yeah, they wouldn't mind living in a house that was 3D printed.
Oh yeah, so it was a huge shift of the mindset and acceptance. Not only in the construction companies who wants to use this technology to increase productivity, but also the end users. So people now, they really like, yes, I'm okay to live in a 3D printed homes, 3D printed home. That's pretty interesting. And we also receiving the inquiries and reservations for the 3D printed homes built in Florida and Texas. Yeah. So today we received more than 350 inquiries from people. They want to get a 3D printed home and they want to put the reservation. So yeah, the response from market was outstanding.
These, I mean, the house, and we'll try and use a picture of it. It's sort of a yellow color, sort of like I think the first residential house. It's sort of like a circular thing, but you built that in Siberia. That must have been very cold. But you actually got it built, and it's the first residential. Actually, Kevin, if you don't behave, we'll send you out there to live there. I think that's the. But the point that those 3D homes, I'm looking at a picture at the moment of a 3D home, which looks brilliant. It looks absolutely brilliant. It's got a Tesla out front as well, so it's even better. But apparently, the cost of those houses is very modest.
Yeah, so the houses that you saw on our website. Yeah. So basically, because the technology allows to reduce a lot of internal costs, even like on the finishing works, on the finishing materials. So our goal is basically to introduce the technology to a lot of different market segments, starting from the low-cost housing to luxury houses. And so the ones that we introduced now on our website, the houses that actually you can reserve to get those built in a year or something, they kind of like within the pretty mid-class market, because we want to have people who really need houses. And they're okay to wait, for example, and they need available houses. So we wanted to target this market.
If you are looking for a house, you know, the fact that it's 3D printed should not scare you one bit, because frankly, the kind of materials that otherwise would build a house, they're actually weaker than the materials that you use, aren't they? I mean, I believe you're about a third stronger than the equivalent blocks that people use to build houses.
Yeah, exactly. So the material that we developed and actively using right now, first, it's the cement-like mortar. And it's 33% stronger than the concrete block. And we tested it in a third-party lab, independent third-party lab. And also, it's not only just the material is strong. The 3D printed walls that we build in, they structurally pretty the same as the concrete block wall. That means that the walls are reinforced the same way as the concrete block wall. So we basically matching the existing building codes, and that the houses are safe and sound, structurally durable because of the material and the way how we reinforce them.
I don't know about you, Kevin, but Anna has given us huge hope today. I mean, we've asked you to run through a very, very challenging. I mean, you've run this business for a little while now. You obviously understand every part of it, and you have to be a driven person to actually achieve the goals that you've got in front of you. How much are you going to put into this, Anna? Is this your life's work? Are you going to be another? It's like the Google guy, Sergey Brin and Sergey Brin and the other guy. The point is, you're a founder of a company that could become one of the biggest companies in the world.
Yeah, so that's quite a responsibility first, because you really need to figure out what the right path, and also believe in your vision and pursuing your vision. Because sometimes it's really easy to get confused, or okay, maybe it's not the right thing. So this is one of the challenging thing. It's really believe in what you're doing and keep doing this, and then you see that okay, that actually worked. So that's kind of like a rewarding thing. But how I came to this, I always wanted to be an entrepreneur. My mom was an entrepreneur, so I just basically look at her I want to do something like this, but I didn't have any idea what exactly I'm going to do. I just knew that I want to be an entrepreneur.
I tell you, the world should thank your mum, because if she wasn't an entrepreneur and she worked, say, in a shop or something, you could have been a great shopkeeper, but you wouldn't have changed the world of construction like you're doing right now.
Yeah. I'm really thankful to my mom. She really showed me what it's meant to be an entrepreneur. Sometimes you really need to, you actually have to work very hard, but you also can have a free time when you can do whatever you want. And also I decided to, because I didn't know what exactly I want to do as an entrepreneur. And I decided to spend my time at university in learning something inspiring, fundamental, and interesting. So I decided to go study space physics. I thought okay.
So Anna, are you a rocket scientist then? Is that what you actually are?
No, it's not a rocket science. It's just the space physics. So
no, I don't know. I think
it sounds
had a rocket scientist on the podcast, Graham.
I mean, if you put our brains together, Kevin, it wouldn't be a third of what Anna's is. I mean, it must be amazing.
Absolutely.
But seriously though, this idea of space physics, are you finding things that you did when you're at university are coming back to help you?
Oh yeah, absolutely. So that was kind of the idea, because the friend of my mom, for example, and my mom, she studied math, the 5 years studying math. And then I started she's doing her own business, and her friends, they also studied something fundamental, like a biology or in chemistry, and they were successful entrepreneurs, so in a very big scale. And then I decided that, okay, I need to study something fundamental, because I saw that this fundamental education will help you to navigate through the life and make the right decisions, because your mindset and how the way your brain works, it actually can help you to do the right decisions in everything you do. Even you're entrepreneur or a taxi driver or whatever you do, you've got the fundamental education, and your brain kind of put in the right order.
I honestly, Kevin, we could spend the next 5 hours talking to.
Oh, we could.
But she's got the world to build. Anna, you've been an absolutely brilliant guest on the next 100 Days podcast.
Graham, I am just fascinated with the way technology is going at the moment. Yes, I've had some experience of 3D on a small scale.
Yeah.
Perhaps printing a house that would sit on top of my desk.
Yeah.
Do you know I'm a railway modeler? I love building things, and I've got not a printer, but I've got a cutter as well. And the advantages you get as soon as you start attaching a computer with a piece of design software to a machine that can make stuff, you can produce the same thing to the same really infinitesimal errors of accuracy time after time after time. And that just fascinates me. A similar vein, I'm discovering so much around in artificial intelligence at the moment that we're seeing some fantastic things going on this planet right now.
The thing about Apis Cor and Anna and the team there is that, I mean, first of all, they're brilliant people. They're really brilliant people. And I think that right towards the end of the podcast, and Anna was explaining the sort of the clarity of thinking that a purist subject at a university gives you. Wow, that was an eye-opener for me. And because what drives these entrepreneurs is that clarity of focus and of the dream as well. And the idea of coming along, and she has got significant competitors out there. I mean, there are people who want to eat off her plate, but they're just not as good as them. There's an opportunity for investors to get involved with this. And if you're in the UK and you would really like to know more, then we've got a really interesting and simple way for you to get in touch. What you do is you write on an envelope, free post VIP, nothing else, just that, free post VIP, and in the envelope just put your name, address, email and phone number, and just mention the fact that you're interested in Apis Cor. And what we'll do is that will enable Apis Cor to get your information, and then they can follow you up and give you a call and send you more information. So that's one of the ways in which you can do it. We'll also put on the show notes other links to follow to get more information about investing, because you know what, Kevin, this really does remind me of back in the 90s. A friend of mine was a beta tester for Google. And I was one of the first people to experience Google. Nobody else in my circle had any idea what I was talking about when I was mentioning Google and search and so forth. And it was like a revelation. They'd done something simpler, better, quicker than the existing alternatives. They'd really thought through the way in which we wanted to search and change the market because of it. And I seen Anna and Apis Cor exactly the same sort of principles. It's just that they've got some fantastic robots. They've got, they've thought through the process of building properties in situ, not 20 miles away. And you imagine some of these gantries we were talking about. Imagine getting onto some sites that you're aware of. They just sink. Some of the sites that there might be down tracks and so forth. And it wouldn't be the easiest thing in the world to get the gantry set up where you want it to be set up. So I really do think they've got a competitive advantage. And, if you're interested, then there's an opportunity right now to invest in Apis Cor. And all I would say is it's been a fantastic podcast, Kevin, with a great entrepreneur and somebody I'm sure we'll hear an awful lot more about.
Indeed. I just still find that corporate escape type story, where it goes to, and this one isn't just a recent corporate escape. It's something that's been going a little while and has had a lot of funding put into it so far, but it looks as though it's really going to go somewhere. So I'm watching with interest, Graham.
Well, today I've been Graham Arrowsmith.
I've been Kevin Appleby. Goodbye.
Goodbye.